Okay, so 2.6. Okay, so a lot of this, again, is stuff we've already done. We've already talked about residuals back when we did, section 114, when we were talking about regression then. So this is just more of the same. It's more practice on the calculator, more practice on Desmos, and we're going to go over the notes again, make sure you're good. But again, none of this is really, really new. We've already done it. This is just another section on doing regression and proving what type of functions, what type of regression you're supposed to be doing for your function. So for this section, we're concentrating specifically on linear, quadratic, and exponential. Okay, so again, this is just notes, right? And giving you those statements that we look for in both the multiple choice and those statements that you're expected to make when you do those FRQs, right? Why would something be linear? Because there is a constant rate of change, or relatively in this case, because obviously not perfectly linear, because obviously the dots are not all on the line. Okay, so quadratic, the rates of change are increasing or decreasing at a constant rate. That's the same as saying that the rates of change are linear. Remember, that was the other way that you could describe it, that the rates of change are linear because they're going up or down at a constant rate. And then again, also depending on what you're doing to prove something, this is also where we were talking about how your second differences are constant, right? So there's all different kinds of things that we can describe it and say with it. And again, this is the kind of things that you'll be expected to say. So we're going to keep, emphasizing and making sure you've got those words, in your mind. Okay, so exponential. And this is the word that I was telling y'all about before, and I kept trying to push at you when you were taking your quiz, I think, that the output values are proportional, right? They are the pattern of repeated multiplication, whether it's multiplication by a whole number or a fraction, right? But specifically that they are proportional, right? And I had said before that if you're going to find your differences follow a multiplicative pattern. Like you can tell when you do your differences that you keep getting this repeated pattern. You can see that you are multiplying by the same thing every time. Okay. So again, just notes. Okay. So again, some that you do without a calculator, some that you do with a calculator. I do have my calculator up and ready. So I will be going over the steps with you to make sure you're good and how we find our residuals. Okay, so, and we will do that more in class tomorrow as well. Okay, so let's see, 0, 11, all we're doing is just graphing the points. 2 is a little bit more than 8, so about right there. 4 is 5. 4 is 5. 6 is 2.3, again, a little bit more than 2. And 8 is -1 down here. Okay, so taking a look, this is definitely going to be a linear regression if we were to actually run the regression on it, right? We can tell by the data. That's kind of why we do, right, that step 2 where you've put your X and your Y values into your spreadsheet, why we then do a statistics page so that it will arrange the points for us and show us what kind of a pattern it is. All right, so -1, 2, 1.5, 5.5, about right there. 4, 10.5, about right there. Okay, 6.5, 5.75, a little bit higher there. And then 9, 2.25. Okay, and again, very obvious from the graph. As far as the 3 choices that we have, this is definitely going to be quadratic, right? It follows a curved pattern that looks like a U or an upside down U. Okay, so the next one, 110. 3 is at 5.2. Okay, 5 is at 2.4. 7 is at 1.3, and then 9 is 0.7. Okay, so your first thought might be linear, right? Especially if you have a little bit of a hard time as far as with the graphs. But this one is exponential. It looks like it's losing almost half every time. Think about like when we did the tennis balls, right? As far as how much they were supposed to bounce. This looks like it's losing close to half every single time, maybe a little bit less than half. But it is decreasing proportionally, not constantly. It's not decreasing by the same amount every time. It is definitely decreasing by a proportion or a percent of what was there. All right, so -2, 2, 1, 3, 4, 4.5, 7, 6.75, oop, a little bit lower than that, and then 10, which would be over here, 10.25. Again, we have that thought process that it might be linear. Again, you could fit a straight line through this, but as far as like best fit, it's not going up again by a constant rate. And you could prove it using your differences, or you'd actually have to use your average rate of changes. Oh, no, never mind. We have the x's are intervals of 3. So we could actually do our differences since they all match. They are those equal length input intervals, right? They're all intervals of 3. So we could find the differences. So 3 minus 2 is 1, 1.5. That would be 2.25 maybe, I think, 2.25. And then that would be 7, 8, 9, 3.5. So they're not going up by the same amount every time, right? But they are going up by some kind of proportional pattern, right? Okay, so that is definitely exponential. In this case, it's getting bigger, so it would be an exponential growth. Okay, so again, we know how to do regressions. We know how to do them in the calculator. We know how to do them in Desmos. So the big thing, again, that we're going to go back over today is residuals. Okay, so the big thing about residuals, it is the actual output value, whatever data point you're given, right? And specifically, since it's the output, it is the y value of whatever data point you're given, minus your predicted output value, and that's whatever is from your prediction line, right? There's a reason I was harping about how to write these equations correctly, right? That's like substituting the x into the prediction line. You're going to get one value, and then your actual data point is going to be another value. And it is always real minus predicted, which is why if your residual is positive, it means that your real was greater than the predicted amount. And if your residual is negative, then it's less. Okay, that kind of makes sense that the point would be above the prediction line, so your residual is positive. Okay, but we are specifically looking at the y values. All right, and that's what we're talking about for residuals. Okay, so we're going to go ahead and put this into the calculator, and we're going to run through so that we can actually get the prediction line. We can see what it looks like, and then we'll talk about how to actually graph our residuals. Okay, so let me go ahead and pull up my calculator just to make sure we're there. And I'm going to go ahead and type in, we need a spreadsheet, right? That's the first thing we do. All right, so I'm going to go ahead and type in these values. My x values, or the t in this case, are 0, 1, 2, 3, 4. And again, I can call it t, I can call it x. If it makes you feel better, you can just call it whatever it calls in the example. All right, so the output values are 3.2, 4.2, 5.1, 5.8, 6.4. Okay, and again, I can call this whatever I want. This thing calls it W of t, which is fine. You can name it whatever you want. Oh, apparently it doesn't like that one. All right, so I'm just going to call it W because it's comparing birth weight by age, I'm assuming, and it's age in months. Okay, so again, whatever you call it, X, Y, TW, whatever, just remember the only reason we even name it anything is so that we can actually graph and name the axes so the calculator knows which way we're putting the data in. All right, so remember, after we do this, we add another page, and that page must be a statistics page, so we automatically get the graph. Down here is going to be my T or my X. Over here is going to be my W. Okay. very, very obvious linear pattern, right? So we know we go back to the first page, okay, and we hit menu so that we can actually run the regression. That's statistics, calculations. I picked the wrong one. Cancel. Let's try that again. So menu, statistics, calculations. I hit the wrong one. A plus bx. There we go. So this is the t, this is the w. I want to save my equation. Okay. All right, so I have a slope and a y-intercept, right? A starting point and what we are going up by every single time. So it looks like my starting point is 3.34, so 3.34 months basically. Or rather, that is the weight in kilograms, is 3.34 kilograms at 0 months old. And that it's going up by 0.8 kilograms every month, right? That would be how we would write it as a regression equation. So I'll actually go back to the notes and we'll write that in. Okay, so that is going to be predicted weight equals 3.34 plus 0.8 times months. All right, that is what we are actually looking at it. Okay, so we're going to figure out, so we did that, the regression. Then we're going to see, okay, we have a prediction, and then we're also doing a residual. So we're not actually even doing a residual plot yet. Right now, we're just doing the normal things. We're making a prediction based on this, and then finding out what the residual is for an actual point. Okay, so we want to predict the weight of a baby that is 2.5 months after birth. Okay, so this is just a plug and chug. We already know the predicted weight. All right, this is the reason why we write these in words. Equals 3.34 plus 0.8 times 2.5 months. Okay, and this is just multiply and substitute. So let's see. I'm going to go back to the calculator. Add a page. I need a calculator page. Okay, so 3.34 plus 0.8 times 2.5. Okay, 5.34 kilograms. That's basically what we're talking about as far as our answer. Okay, so, and make sure, please, that you are putting your units for your answers. Okay, so the actual weight, this is where we get into the residuals, the actual weight of this specific baby at 2.5 months was 5.5 kilograms. So imagine, right, that again, the predicted is 5.34. Just to give you a visual. The predicted is 5.34 at 2.5 months. So here, 5.34 is right here about where the prediction is. And this baby weighs 5.5 kilograms. Okay, so think about that. Our residual should be positive, right? Because the baby weighs more than what it is predicted to weigh. So literally 5.5 is the actual, right? The actual data point minus 5.34 equals what? 0.16 kilograms more than predicted. Okay? So if the baby weighs more than predicted, then what you would say is that the prediction underestimated the weight. So this would be one of those babies that's probably like in the 90th percentile, right? It weighs more than what it's predicted to weigh based on its age. Okay, so tomorrow when we get into class, we're going to go over the steps because I want you to be able to write them down because you need to add them to the other steps you have on how to find the residual plot. We already caught how to do that in Desmos. It was very, very easy. I want to make sure you can do it on the calculator because, again, we still don't know which calculator. So I'm going to make sure you are prepared to use both. All right, see you tomorrow.